Welcome to the demonstration of our peer-to-peer energy trading platform for community microgrids. This system empowers local prosumers, those who both produce and consume energy, to trade their surplus solar power directly with their neighbors. This project is a collaborative effort between the National Institute of Technology Calicut, National Institute of Technology Tiruchirappalli, Epixel Solutions, and Auroville Consulting. We are grateful to the Central Power Research Institute, Bangalore for their vital funding through their RSOP scheme, and to the Auroville community for hosting our pilot implementation. Before we begin, let me introduce the key members of our team. Leading our project is Dr. Vivek Mohan, Assistant Professor at NIT Calicut, as our lead investigator. Working alongside him is Dr. Karthik Tirumala, Assistant Professor at NIT Tiruchirappalli and our co-principal investigator. Our industry expertise comes from Mr. Dane Saridas, CTO of Epixel Solutions, and Mr. Martin Skeffler, Executive Director and Co-founder of Auroville Consulting. And our dedicated research team includes Dr. Jacob Varghese, Senior Research Fellow, Mr. Anit Krishnan, PhD Scholar from NIT Calicut. I am Srivatsan, an MTech student at NIT Calicut. I am currently extending this platform with new features as the focus of my master's thesis. Technically, this platform is built on a private Ethereum blockchain using a proof of authority consensus to run a secure day-ahead market. Transactions are automated via smart contracts, while a novel trading algorithm allows users to represent recurring orders based on historical data, minimizing manual input. The system integrates smart meters via a Django backend, and users interact with the market through both web and Android apps, connecting directly to the blockchain with MetaMask. Once a user logs into their secure account, they land on the main dashboard. This is their personal hub for managing and tracking all their energy trading activities. The first thing you see is energy usage graph. The green line indicates the excess energy or the surplus energy that has been exported back to the grid, while the red line indicates the imported energy from the grid. User can easily select any date to review their historical consumption and the energy generation pattern. For instance, for 15th of October, this is the energy usage graph. To the right, for instance, for October 15th, this is the energy usage graph. To the right, you will find the limits for tomorrow's energy trading. This table is really helpful. It shows the maximum units you can buy or sell in the upcoming peak, normal and off-peak time slots. These limits are intelligently calculated by the system based on your energy usage over the past 7 days. This helps keep the trading environment balanced and ensures that the commitments are realistic. Now scrolling down, we reach to the quote for solar energy for the next day section. Here users can choose date, select a slot. Slot can be like peak, normal and off peak. Then they can choose whether they want to buy or sell and the number of units and also the price that they want to buy or sell it. Next to it, we have the grid price table, which shows the standard energy rates set for different time slots throughout the day, peak, off-peak and normal. On the right, there is another panel called Apply Standing Instructions. This is where user can automate their trades by setting a range of dates, choosing the slot and action, and defining limits like maximum buying price, minimum selling price and units. If they pick auto, the system automatically adjusts these values based on the previous week's trend. If they prefer, user can also set manually, giving them full control. For instance, on October 15th to October 18th, anything of the user's choice, and the action auto buy or sell, maximum buying price and minimum selling price, and they can submit the bid. Below that, there is this details of placed order. This shows any bit or order made from the upcoming days. Next to it, we see the details of the standing instruction, listing all types of automated instruction users are applied, including from to date, slot, action type, maximum and buying price, minimum selling price, and the number of units. Each entry also has a delete button, or the user can remove any instruction anytime. Finally, at the bottom, we have 3 more sections: submitted bits, executed bits, and cash settlements. Each one allows the user to pick a date and view detailed records by clicking the respective purple buttons. Submitted bit shows the bits that the user sent in for that specific date. Executed bit displays which one of these bits were actually completed. Cash settlement summarizes the final transactions: first settlement, second settlement, total cash, and its hash value for verification. By pressing submitted bits, you can see all the bits that has been submitted on October 15 along with the hash value. The same applies to executed bit also. For cash settlement, on that specific day, the first settlement, the second settlement total that equals to around 109.50, and the total cash is the sum of first and second settlement together along with the final hash value. And that's how the Auroville token platform works overall, from logging in, checking energy usage, splitting up trading preferences, and automating instructions to review bits and settlements. It's a complete, easy to use system for managing community based energy trading. Welcome to the admin dashboard for Auroville Energy Tokens. This is the central control panel where the grid operator can manage and oversee the entire peer-to-peer energy market. Let's walk through how it works step by step. The dashboard gives a clear, organized view of entire trading lifestyle, from initial bits to final blockchain-verified cash settlement. We will start with the bits section. Here the admin can select a date range and view all the raw manual buy and sell orders that the users have submitted for the day ahead market. This table is the starting point. It's a direct log of our participants' initial intentions. For instance, let's choose from 8th October to 10th October. And the data can be viewed in the CSV file. Next is the updated bits. This is where the platform's core algorithm comes into play. This table doesn't just show the raw bits, it shows the validated bits that are eligible for matching. This validation is a systematic process designed to ensure a stable and reliable market. First, the system applies trade limits to each user for each time slot. These limits define whether a user can buy or sell and the maximum quantity they can trade. The trade action, buy or sell, is determined by forecasting it. If a user was a net exporter of energy over the past 7 days during a specific time slot, the user restricts them to a sell order for that slot, and vice versa for a net importer. The trade quantity is also forecasted conservatively. It's calculated as average difference between the energy generation and consumption over the past 7 days, scaled by a safety factor. This mitigates the risk of users over-committing to trades. Secondly, the system intelligently handles both manual order and automated standing instructions. A valid manual order will override a standing instruction for the same time slot. However, if a manual bit is invalid because it violates the trade limits, it rejects, and the system will instead process a valid standing instruction if one exists. The final results in this clean, updated list of bits ready for matching. Let's again take the same example as 8th October and 10th October. After pressing the view, different bits for each user can be seen. 1, 2, 3, 4 till 8 users for peak, off-peak and normal hours, and for different dates. Let's move on to the scheduled transaction. This table shows the first schedule which is generated by matching the validated buy and sell order from the previous set. To create this schedule, the platform uses a greedy matching algorithm. It takes the highest buy bids and matches them with the lowest sell offers. This approach ensures that we maximize the number of successful trades, with the buyers getting the lowest possible price and sellers receiving the highest possible price. The final price for each trade is calculated to be fair for both parties. If it is simple average of the buyer's bid and the seller's offer, as shown by the formula, P of ij is equal to half of P of I plus P of j. Again, from October 8th to October 10th. These are for each user. Again, we can see for normal and the actions taken and the number of units as well as the price correspondingly. This is being displayed for the different date that we chose. Next up is the actual energy section. The actual energy section shows us the ground truth. This data is pulled directly from the data meters installed at each user's home and shows the real amount of energy that imported or exported during the day. This is crucial because what was scheduled isn't always what happens due to fluctuations in generation or demand. This data is essential for final step. Again, let's take the same example, 8th October to 10th October. And this is for user 1, during peak hour, he chooses the buy action for 3.85 units. And by scrolling, we can respectively see all the bids have been placed by different users for different dates. And also there is a CSV option to download the data and refer it for future reference. At last comes the cash settlement. This is where we reconcile the initial plan with the real world data to calculate the final financial outcome for every user. The process involves two calculations. The first settlement is the amount based on initial agreement from the scheduled transaction tab. The second settlement is a crucial financial adjustment. It occurs for any deviations between the scheduled trade and the actual energy exchange, as recorded by smart meters. Our platform uses a generalized mathematical model to calculate this adjustment, ensuring all participants are compensated fairly for their actual energy usage. So this is the user 1 to user 8 first settlement data. For instance, for user 1, the first settlement is 0 and the second settlement is 78.78 on October 8th. The total cash is the sum of these two settlements, providing a complete and transparent financial record. And of course, the data from any of these sections can be downloaded as a CSV file for future reference. Now let's address how we ensure all this in a secure and trustworthy. Back on the main dashboard, we have this logs and automation op. This takes us to the blockchain control automation page, the brain of the system's integrity. After a trading day is complete, the admin selects the date and clicks Start Automation. This action triggers the system to record the day's finalized transactions onto a private Ethereum blockchain. We use a proof of authority consensus mechanism, which is highly efficient and secure for private network. Smart contract automatically manage and execute the settlements, ensuring the process is tamper-proof. Using blockchain guarantees that every transaction is verified, traceable, and immutable, making the entire energy trading process transparent and trustworthy. And that is how the Auroville Energy Token platform empowers an admin to manage the full cycle of energy trading, from initial bids and algorithm validation all the way to final settlement and blockchain automation. It is a comprehensive, transparent and reliable system designed for the future of community energy market. Thanks for watching.